Good morning. Welcome to Math 93. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@yvcc.edu and I'll respond as soon as I can. All right, so today, we're going to be reviewing for our first test. Let me remind you how that's going to happen. So tomorrow, actually, you can take your test anytime up until tomorrow night at 11:59 p.m., in which case it shuts down. Once you open it, you have a set time to take the test. There will not be any class tomorrow. So if you show up at 10:30 tomorrow morning for a Zoom meeting, there'll be a sign that says, no class today, just take your test. Okay, I will have an office hour tomorrow afternoon, but that's not for you to ask questions about the test. It's basically for the other class, the Math 95 class. Anyway, so we're going to get started here. I've got a bunch of questions people asked for me to do, so I will do those first, and then we'll get to any other questions you might have. Okay, so this first one is from section 14.3, starting out with number 11. Let me remind you that you all have the same kinds of questions, but different numbers. So if this does not match your number 11 on 14.3, don't panic. This says, insert 4 geometric means between 5 and 1,215. All right, so we know that our first term is 5. Then we are going to insert 4 geometric means. So there's 1, 2, 3, 4 of them, which means that our last term, 1215, would be a sub 6. So we've got the first term, the last term, and 4 geometric means between them. All right. Since we're looking for geometric means as opposed to arithmetic means, we're going to be using the formula for geometric sequences, which is a sub n equals a sub 1 times r to the n minus 1 power. All right, we know that a sub 6 is 1215. So a sub 6 is 1215. We also know that a sub 6 is a sub 1 times r, the unknown common ratio, to the n minus 1 power, which would be to the 6 minus 1 power, which means a sub 6 equals 5r to the 5th. So we've got a sub 6 equals 1215, a sub 6 equals 5r to the 5th. All right, which means this equals that. So that's going to form our equation. 1215 equals 5r to the 5th. We're trying to solve for r. So first of all, we need to isolate the variable r by dividing both sides by 5. So on the right side, I get r to the 5th. On the left side, let's see, 1215 divided by 5 is 243. So now the question is, what number times itself, times itself, times itself, times itself? In other words, 5 identical factors are 243. Well, let's take 1. 1 times 1 times 1 times 1 times 1. Well, that's just 1. Whoops, 1, not 5. So it's not 1. How about 2? 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. How about 3? 3 times 9, 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. So if we take the 5th root of r to the 5th and the 5th root of 243, we get r equals 3. Okay, so if r equals 3, a sub 1 is 5, a sub 2 is 5 times 3, which is 15, a sub 3 is 15 times 3, which is 45, a sub 4 is 45 times 3, which is 135. Let's see, is that right? Yeah. A sub 5 is 135 times 3. Let's see, 135 times 3 is 15, so 405. And 405 times 3 is 1215. So the 4 geometric means would be those right there. Any questions about that problem? Okay. Let's take a look at 14.3, number 12. It says, insert 3 geometric means, 2 positive and 1 negative between negative 128 and negative 2048. So A sub 1 is negative 128. We're going to insert 3 geometric means. So A sub 2, A sub 3, A sub 4, and then our last number, A sub 5, is negative 2048. Okay, we're basically going to do the same thing we just did a minute ago. We're going to use the fact that A sub n equals A sub 1 times r to the n minus 1 power. A sub 5 is negative 2048. A sub 5 is also A sub 1 times r to the 5 minus 1 power. So A sub 5 is negative 128 r to the 4th, and A sub 5 is negative 2048. So negative 2048 equals negative 128 r to the 4th. Negative 2048 equals negative 128 r to the 4th. Then we'll divide both sides by negative 128. Let's see here. On the right side, we get r to the 4th. And on the left side, negative 2048 divided by negative 128 is 16. So r to the 4th equals 16. Well, 1 times 1 times 1 times 1 is 1. 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So if I take the 4th root of r to the 4th, I get r equals 2. But keep in mind, we talked about the other day that negative 2 could also be that, because negative 2 times negative 2 times negative 2 times negative 2 would be positive 16. So r is either positive 2 or r is negative 2. Now, let's go back to the directions. It said, insert 3 geometric means, 2 positives and 1 negative. If we use r equals 2, this becomes negative 256, negative 512, negative 1024. That doesn't give us what we need, okay? Those are all negative. But if we choose r as negative 2, negative 128 times negative 2 is positive 256. 256 times negative 2 is negative 512. Negative 512 times negative 2 is positive 1024. And 1024 times negative 2 is negative 2048. So this was just their way of saying r is negative, but you had to figure that out in terms of how could you get 2 positives and 2 negatives. So then again, this would be the 3 geometric means that are inserted. All right. Any questions on that before we go on to the next example? Okay.
Is r to the 4th the same for r? Could you do it that way?
Say that again. Is r to the 4th the same as just plain old r?
No, for r. So like
No. R to the 4th is not the same thing as 4 times r. For instance, let's take a look at this. Okay. Negative 2 to the 4th power is 16, but negative 2 times 4 would be negative 8.
Okay.
So r to the 4th is equal to r times r times r times r.
Yeah.
All righty.
Okay.
Okay, let's see here. What are we doing now? We've got to go back here and here. This is chapter review. Number 10. Okay. So this is for the test. This is the test review material. And this is number 10. It says the first three terms of an arithmetic sequence are 5, -5, and -15. Find the 101st term. Okay, now, since this is an arithmetic sequence, we're going to use the formula a sub n equals a sub 1 plus n minus 1 times d. Just a reminder that I mentioned the other day, n minus 1, that you can have these two formulas on a piece of paper while you're taking the test. That's all, but you can't have those. You can. Okay, so what we've got here is we need to find the common difference. Recall, with an arithmetic sequence, to find the common difference, you take any term minus the previous term. So -5 minus 5 would be -10. Okay, so d equals -10. So a sub 101 is a sub 1, which is 5 plus 101 minus 1 times -10, which is 5 plus 100 times -10, which is 5 plus -1000, which would be -999. No, excuse me, -995. Okay. Any questions about that one? All righty. That takes us to, let's see here. That one there. And again, review questions. Okay, so this is test review material, and this is number 9. It says, find the first 4 terms of the sequence defined by a sub n equals 5n minus 6. Enter your answers as a comma-separated list. Okay, so we are to find the first 4 terms. So recall, if it says an arithmetic sequence, you use that formula. A geometric sequence, you use that formula. If it just gives you a specific formula like it does here, then we use this. So a sub 1 is 5 times 1 minus 6, which is 5 minus 6, which is -1. A sub 2 is 5 times 2 minus 6, which is 10 minus 6, which is +4. A sub 3 is 5 times 3 minus 6, which is 15 minus 6, which is +9. And a sub 4 is 5 times 4 minus 6, which is 20 minus 6, or 14. So your answers would be -1, comma, 4, comma, 9, comma, and 14. Any questions about that problem before we go on? Okay, this is also from the test review. This is number 12. Find 2 arithmetic means between 8 and 28. So a sub 1 is 8, then we've got 2 arithmetic means. So a sub 4 is 28. We're going to use the formula a sub n equals a sub 1 plus the quantity n minus 1 times d. All right, So I know that a sub 4 is 28 because that's given. I also know that a sub 4 is a sub 1, which is 8 plus n minus 1, 4 minus 1 times d. So a sub 4 is 8 plus 3d, and a sub 4 is 28, which means 28 equals 8 plus 3d. 28 equals 8 plus 3d. Subtract 8 from both sides, 20 equals 3d, divide by 3, d equals 20/3. Now, I've mentioned this several times, but I'll mention it again because I keep getting questions from students saying, why is this wrong? You can't take 20/3 and round it off to, I think it's like 6.6 repeating. Okay, you can't use a repeating decimal and round it off and expect it to be correct. So the best way to go is to just use the fractions, in this case, the improper fractions. Okay, now that I know that 20/3 is the common difference, a sub 2 is going to be 8 plus 20/3. But 8 is like 8 divided by 1. And to add these, I need a common denominator, which is a 3. So I'm going to multiply 8/3 by 3/3. So I get 24/3 plus 20/3, which is 44/3. Okay, 44/3 plus 20/3 is 64/3. So this is 64/3. To confirm that that's correct, 64/3 plus 20/3 would be 84/3, which would be 28. So it checks. So the two arithmetic means are those. Any questions on that one? Okay.
Mr. Mayo,
Yes.
would you, what's the easiest way to put that into WebDesign? Because putting in fractions in there sometimes makes it doesn't turn out the right way.
Are you putting in fractions or are you putting in mixed numbers?
Mixed numbers, I think.
Let me repeat again what I've said. Don't use mixed numbers
Or
in
no,
WebDesign.
no, not mixed numbers. If I put in like 84/3, or not 84/3, because that'd be 28, but 64/3, then is there a way, because sometimes it'll separate it out. So it looks like 64, it'll have the dash, and then it has a big space, and then it'll have a 3 when you try and put it in to WebDesign. And yeah, it kind of takes, is there a trick to it at all?
There shouldn't be. Tell you what,
Okay.
Let's put a hold on that question. We'll put a pin in it.
Okay.
I'm going to do the other two questions, and then I'm going to go into, actually, you know what? We can do it now. You can do it now. Hang on.
Okay.
I was thinking I'd have to change a whole bunch of stuff, but I don't think I will. So let's see if I can do this. Okay. View. I know you can't see what I'm doing. Hang on a minute, and I will open up that screen. Okay. All right. So now you can see WebAssign, right?
Yes.
Okay. Now, I'm not going to do this actual problem. I'm just going to put in a fraction. So let's say I want to put in 64/3. Okay. Now, notice when I clicked on that, a screen came up over here. But even with just 64/3, all I have to do is go 64. And then I hit that, okay, hang on. Let's see here. '64, and then there's this slash button. It's down on the keyboard. It's like the bottom right next to the shift key on the right. It's right below the question mark.
Yeah.
Okay, so using that, if you've got just a fraction like this, and you put it in, that should be acceptable.
I don't think I had, sorry, I realize now, I don't think I had a problem with just doing one. I think it was when I did two together. So when you had to do one fraction and then comma and then one, that's where I had a problem.
Okay. Now I know what the problem is. So let's say my answers are 64 thirds, 75 thirds, 81 thirds. Okay, something like that. All right. Now, let's go back to well, let's stay in the screen first of all. If I put in 64 thirds and then I hit a comma, it does this. It puts it in the fraction. It's in the denominator of the fraction. So what you've got to do is you've got to use the right arrow key and get out of that fraction. So let's go back here to the WebAssign screen. Okay. Now, so I put in 64 thirds, comma, and then I go a space or whatever, and then I put in 75 thirds, comma, and you get this big mess. Is that what's happening?
Yes, exactly.
Okay, so what you've got to do is here, so after you put in the number, use the right arrow key on your keyboard, and then move so that you're outside of the fraction. Okay?
Okay, thank you.
Yeah, and same thing if instead of using just the slash, let's say I use this thing here. Okay, so I've got 64 thirds. That's going to be wrong. I've got to move that right arrow key and get outside of it. Yeah, okay with that?
Yes, thank you.
You betcha. Yeah, I'm glad you brought that up because that's the kind of thing that not everybody gets used to. And okay, so let's see now. Let's go back to this screen, and we finished problem number 12. I think, were there any questions left on 12? All right, so now we're going to look at the review number 14. And I've got to go back here to this person's problem. Okay. All right, this says, write the first 5 terms of a geometric sequence whose 4th term is 5 and whose 5th term is 5 halves. So a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. The 4th term is 5. The 5th term is 5 halves. Okay. Geometric sequence. So a sub n equals a sub 1 times r to the n minus 1 power. I need to find r. Now, with an arithmetic sequence, you take a term in the sequence minus the previous term to get the common difference. In a geometric sequence, you take a term divided by the previous term to get the common ratio. So this is 5 halves divided by 5, which is 5 halves divided by 5, which is 5 halves times the reciprocal 1 over 5, and that reduces down to 1 half. So the common ratio is 1 half. All right. Now, we've got to think backwards. To get from a sub 1, let's say a sub 1 equals star, okay? A sub 2 would be 1 half times star. A sub 3 would be 1 half times 1 half star, etc. So moving forward, you're multiplying each term by a half. So moving backwards, instead of multiplying by a half, you would be dividing by a half. So to get from here to here, I'm going to divide by a half, okay? But dividing by a half is the same thing as multiplying by its reciprocal, 2. So that means from here to here, I'm going to go times 2. Isn't 5 halves times 2 equal to 5? So 5 times 2 is, 5 times 2 is 10, times 2 is 20, times 2 is 40. Now, it says, use your, enter your answers in a common separated list. I guess this one, since it doesn't have fractions as the answers, it wouldn't be a problem. You'd have 40, 20, 10, and 5, and then 5 halves. We okay with that one?
Yeah, on the corner with the 5/2 times 1/5, how do you get 1/2 again? I was writing notes, I just forgot.
Okay, say it again. Here?
No, on the right.
Here?
Yeah,
Okay, okay. So dealing with this right here.
Mhm.
5, oops, hang on, sorry. So 5 halves divided by 5 is 5 halves divided by 5 is 5 halves times the reciprocal of 5, which is 1/5. Dividing by a number is like multiplying by its reciprocal.
Mhm.
But then here, I can come in and reduce the 5/5, and I end up with just 1/2.
Oh,
You okay with that?
yeah.
All right, any other questions before we go on? We've got one more example that somebody asked about. Okay, so this is review question number 15. Find the first term of a geometric sequence if it has a common ratio of -5, and the 9th term is 3,125. So a sub 1, we're supposed to find the first term. The common ratio is -5, and the 9th term is 3,125. Okay, since we're dealing with a geometric sequence, our formula is is a sub n equals a sub 1 plus n minus 1. Oh, that's not the right formula, is it? Nope. A sub 1 times r to the n minus 1 power. I was getting confused because I was thinking about, if it was me, instead of, for the geometric sequences, I would have used terms of g sub n instead of a sub n, but that's just me. Oh, well, okay. So a sub 9 is 3125, right? But a sub 9 is also a sub 1, and I don't know what that is, times r to the negative, so that's -5 to the 9 minus 1 power. So a sub 9 is a sub 1 times -5 to the 8th power, okay? So a sub 9 equals that, a sub 9 equals that. So now I've got 3125 equals a sub 1 times -5 to the 8th power. Are we okay so far? So let's take -5, and notice it's not a negative sign outside, it's the quantity -5. So the quantity -5, close up the parentheses, raised to the 8th power. Wow. And that is 390,625. Okay. So now I'm going to divide both sides by 390,625. 390,625. So a sub 1 is 3125 over 390,625. Well, now I've got to reduce that thing, okay? I'm going to take this and write it on the next page. So before I do that, does anybody have any questions about what happened so far? Okay, so a sub 1 is 3125 divided by 396.25. 396.25. Okay. I want to reduce that thing. Well, you know, the first thing I would do is just take a stab in the dark and see if 3125 goes into 390,625. Let's see if it does. So I'm going to take the denominator divided by 3125, and it does. So this divided by that is 125, and the numerator divided by that is 1. So basically, I can reduce that down to that. Now, would WebAssign accept this answer? I don't know. I wouldn't. I'd say you need to reduce it. Okay. Anyway, we okay with that one? Any questions there? Okay. Do you have any other questions, specific questions you'd like to ask before I go ahead and start looking at other review problems that I'm just gonna look at? Okay, so give me a minute here. We're going to switch to that. Okay. Now, let's go. This is going to take me just a minute here, so hang on. Don't run away. Okay. So now we'll change it to that screen. Okay, so now can you see the whiteboard on the right and WebAssign on the left?
Yes.
Okay, great. So let's go back and let's review what happened in 3.7. Okay, in 3.7, we were graphing inequalities. And what I actually want to do, just to kind of cover all my bases, is I'm not going to graph. It's not what I wanted to do. I'm trying to move this thing right there. I'm not going to graph the one that was there. I'm going to make one up that has some tricky numbers so that we can deal with what happens with that. Okay, so let's see here. I've got the pin and go with black. So I've got, let's say, 2x minus 3y is greater than 7. Okay, and I want to graph this linear inequality. So the first thing I'm going to do is I'm going to rewrite it as an equation. 3x minus, or 2x minus 3y equals 7. Then I'm going to find 2 points on that line. I tend to use the x and y intercepts unless the line goes through the origin, in which case I'd have to pick a different point because otherwise I'd get 0, 0, and 0, 0. Okay, so for this, let's see, if y is 0, I've got 2x minus 3 times 0 equals 7. 2x minus 0 equals 7. 2x equals 7. X equals 7 halves. Any questions about how I got that? Okay, if x is 0, I've got 2 times 0 minus 3y equals 7. 0 minus 3y equals 7. Negative 3y equals 7. Divide both sides by negative 3, and y equals negative 7/3. Now, how do I graph those 2 points to get an linear inequality? Come over here. Click on this until it turns blue. Let's see. 7 halves is about 3.5. But again, when I click on it, notice how it always goes to the nearest integer value. Negative 7/3 would be negative 2 2/3, so right about there. Okay. But neither one of those points is where I wanted them to be. So I go up here and I click on the line. My first point, I'm going to backspace and put in 7 halves. Okay. My second point, negative 7/3. Oops.
Mr. Mayo, how did negative, how did 7 turn into -7/3?
Because I was dividing it by -3. I had -3y equals 7 from up here, okay? Then I divided both sides by -3. So then I just move the negative sign to the numerator.
Oh, okay, I get it.
All right. But anyway, the point, go ahead.
Is if 7 was negative, it would have been a positive 7/3, right?
Yeah, because a negative divided by a negative is a, whoops,
Positive.
is a positive, yes.
Okay.
Okay, now, so I went in and put my ordered pairs where I needed them. Notice I did not write -7/3 as -2.6 because that's not correct. But it doesn't include the equals, so I need to make it a dashed line. Okay. Now, 2x minus 3y greater than 7. I need to use a test point. So test point. I can use anything that's not on the dotted line. I'm going to go ahead and use 0, 0, because it's a nice one to use. So that goes back into the original inequality, 2 times 0 minus 3 times 0 greater than 7. That is false. So 0, 0 is not in the solution set. Therefore, the other side of the line down here is. So there is the solution to that inequality. Any questions about that example? All right. Let's take a look at another example. Let's see. Tell you what, let's just go ahead and do this one, number 3. So this is from 4.5, where we're solving a system of linear inequalities. Okay. So let's see here. We're still using black. That's good. So my first one is 6x plus 2y less than 12. Okay. So I'm going to look at the equation. 6x plus 2y equals 12. I'm going to use 2 points. I'm going to use the x and y intercepts. Basically, what I'm doing right now is exactly what I did on the previous problem. So if y is 0, 6x plus 2 times 0 equals 12. 6x plus 0 equals 12. 6x equals 12. Divide both sides by 6x equals 2. Okay. If x is 0, 6 times 0 plus 2y equals 12. 0 plus 2y equals 12. 2y equals, oh, I noticed somebody wrote something in the chat, just a reminder, I don't tend to look there. Okay. Tell you what, you remind me, and after I'm done with a bunch of these, I'll come back and do that one. But yeah, or did it disappear now? Well, anyway, okay. So y equals 6. And again, the best way to get information to me is to email before 10 o'clock on a given day, and then I'll have it all written up and ready to go. But I still will do this one that somebody requested if I just remember to. Okay. All right. So 0, 6. All right. So now I'm going to plot those 2 points. So I click on this till it's solid. 2, 0, 0, 6. 2, 0, 0, 6. It's going to be a dashed line because it does not include equals. This is the one I created, but the original doesn't. Okay. So now I've got to pick a test point. I'm going to go with 0, 0. So test point 0, 0. I'm going to put that in here. 6 times 0 plus 2 times 0 less than 12 0 less than 12, that's true. So we're going to fill in there. So that is the solution to the first inequality. If that was all that we had, 6x plus 2y less than 12, we would be done. But we're not. We have a second inequality. So we're going to come back over here and we'll do one in red. And that is 2x minus y greater than 2. So once again, I'm going to look at the related equation, and I'm going to find two ordered pairs. If y is 0, 2x minus 0 equals 2, 2x equals 2, x equals 1. If x is 0, 2 times 0 minus y is 2, 0 minus y is 2, negative y is 2, divide both sides by negative 1, y is negative 2. Any questions about that so far? Let's go back here for a minute. I forgot to do this because in my next step, it's going to get rid of my shading. So I'm going to go over here and remind myself that that's what the first one looked like. Okay. So now let's go over here, click on it. Oh, no, yes, and click on it again. And 1, 0, 0, negative 2, 1, 0, 0, negative 2. That also does not include equals, so that's a dashed line. But which side of that dashed line am I on? Well, let's go ahead and use 0, 0 again as a test point. That's going to go in there. 2 times 0 minus 0 greater than 2. That's false. So it would not be over here. Means it would be over here. Okay. So for the line 1, which was the black information over here, it would be, let's see, here and here. For line 2, which was the red one, it would be here and here. So where do those overlap? They overlap down there. If I take this piece and put it with this piece, they overlap down there. So let's see if that's correct. Now, I've had students ask questions and I've looked at their graphs and I've said, did you come to the Zoom meeting? No. Did you watch my videos? No. And that's why they don't know what they're doing. So before you panic and ask me a bunch of questions, you're supposed to watch the videos or at least attend this Zoom meeting, okay? Because I went into great detail over and over how to graph these things. One of the most common mistakes is that students will graph a whole bunch of points, graph 2 points, only 2 points to form each line, whether it's a solid line or dashed line, okay? If you follow the directions I gave you, things will go a lot easier for you. Okay. Now, we've already taken a look at the other stuff, which was, we haven't done anything with factorials. Let's do this. Let me look at that chat question. And so hang on, I'm going to stop sharing and go back to, let's see here. Just going to go back to sharing my regular screen. And then let me get out of here. And let's see. Chat. Number 4 from the test review. Okay. All right. So this question has been requested. Okay. I can tell you already, one of the things that's wrong, look at this dashed line. There's 3 points on it. Let's see here. Well, I'm not sure what happened there. Tell you what, let's just take a look at it. All right. So can you see my whiteboard in the WebAssign screen? Somebody?
Yes.
Thank you. All right. So let's take 4y less than or equal to x. Okay. So 4y equals x would be the related equation. This is going to go through the origin. So I'm going to have to use something besides just the x and y intercepts. If y is 0, 4 times 0 equals x, 0 equals x, so we get 0, 0. How about if we let y equal 1? So then 4 times 1 equals x, x equals 4. So 0, 0, and 4, 1. Okay, 0, 0, and 4. Oh. I think what happened was they graphed this ordered pair backwards because this is 1, 4, and it should be 4, 1. What you see here that's in green, that's the correct shading, but it's like this one didn't happen. Okay. Let's see. What do I want to do with this? I know what I want to do. Hang on. Let's get the second one, which is y is greater than 4x. Okay. So now I'm going to just share the screen and I'm going to go back to just give me a minute here. Student view. I'm just going to pull up a grid that I can use here to graph this thing. Okay. Sorry, I got to switch things around. Okay, so I'm going to graph it over here. We've got 0, 0, and 4, 1. 0, 0, and 4, 1. It is a solid line because it says it is less than or equal to. Okay. Now my test point, oops, let's go back to black there. My test point can't be 0, 0 because 0, 0 is on the line. How about 4, 4? So that point right there. So that's going to go up here. 4 times 4 less than or equal to 4, 16 less than or equal to 4. That is false. So 4, 4 is not a correct test point. So it would be down here. Okay. So the first one, the 4y less than or equal to x would look like that. Now let's take a look at the second line. This is going to be y equals 4x. If I let y equals 0, 0 equals 4x, divide by 4, x equals 0. So that again goes through the origin. I'm going to let x equal 1. So y equals 4 times 1, which is 4. So we get that one. Oh, maybe that's why that person had the coordinates backwards, but they still only had one line on there. Okay, so now this one goes like that. 0, 0, and 1, 4 is there. 0, 0, 1, 4. This one is dashed. Okay, because it does not include equals. And tell you what, let's go ahead and use 4, 4 again as a test point. That'll work. So we're going to put that in there. 4 greater than 4 times 4, 4 greater than 16, that's false. So for the dashed line, 4, 4 is not correct. So we're going to be over here. Okay, so back to the beginning for a minute. The black inequality is the solid line, and the fill would be here and here. The red inequality is the dashed line, and the fill would be there and there. So where do they overlap? Right there. So that would be the solution to this problem. Okay. Any questions about that? All right, our time is up. So just a reminder, I will be back tomorrow. Actually, I'll be back this afternoon at 1:15 with an office hour if you still have some questions. Tomorrow, there will be no class. There'll just be a screen that'll say, take your test, okay? You can take your test anytime from now until tomorrow night at 11:59 p.m. But once you click on it and open it, the timer starts. No going back, all right? Again, you can have those 2 formulas, the geometric sequence and the arithmetic sequence. Other than that, no help from anyone, all right? So there you have it. And I'm going to stop the recording.